Farhim binti Arban. My registration number is 13DKA21F1040. Now, I will explain about introduction of this case study. Introduction. Water distribution system is to deliver water to consumer with appropriate quality, quantity, and pressure. Distribution system is used to describe collectively the facilities used to supply from its source to the point of using. Good distribution system water quality should not get deteriorate in the distribution pipes. Second, it should be capable of supplying the requisite amount of water during the firefighting. Third, all distribution pipes should be preferably laid 1 meter away or above from sewer lines and many more. Distribution reservoirs. Distribution reservoirs, also called survey reservoirs, are the storage reservoirs which store the treated water for supplying water during emergencies. Sewerage system. Sewers are underground conduits to convey water waste and storm water to the treatment plant or carry stormwater to the point of disposal. Wastewater. Treatment. Wastewater is liquid waste from the toilet and sink water discharged from residential, business, and industrial. The wastewater discussed in this section is predominant of domestic origin. Based on our research, the study area was conducted in Taman Mutiara, Parit Buntar, Perak, Malaysia. The study area, which is Taman Mutiara, Parit Buntar, is residential area located in Parit Buntar, Perak. It is located about 8 kilometers from the city center and is surrounded by several other residential areas, which is Taman Intan, Taman Nilam, and Taman Desa Bengkar. This area is well developed with amenities such as surau, school, clinic, hospital, mosques, and shop. Taman Mutiara is a medium residential area with a population of over 9,000 people. There is a water treatment plant near Taman Mutiara. There is Jalan Baru Water Treatment Plant, Parit Buntar. Location of the study area, Taman Mutiara, Parit Buntar, Perak, Malaysia. Type of settlement, residential area. Number of residents, 1,500 residences. Number of occupants, 9,000 people.
Nama saya Nurahani Smeti Zairani, nombor pendaftaran 13 DKA 21F1203. This is a flow chart of distribution component system at the Taman Mutiara, Parit Buntar. First, delivery main pipe. Second, reticulation pipe. Third, distribution pipe. Fourth, tap water or hydrants. Five, water meter. Six, pipe connection. And 7, tank or pump. Component in the distribution system. Component in the water distribution system consist of tank and water pool, pump meter, fire hydrants, reticulation pipe, distribution pipe, and various type of valve. Okay. 1. The delivery pipe is a pipe that carries treated water from the treatment plant or from the pump house to the storage tank or from one tank to another tank. 2. Reticulation pipe is a pipe that distributes treated water to the supply area. Meanwhile, distribution pipe are pipes that distribute water to reticulation pipe from water storage tank, treatment plant or from booster pump station. 3. Water pump are used for hilly area where the distribution area is higher than the water reservoir area. In addition, the pipe is also used on a wide distribution area to ensure that the water pressure is sufficient for all distribution area. Okay. 4. A water tap or hydrant is a tap that is connected to main supply system, not equipped with a meter, and use the authorities such as the fire department to obtain sources of water supply for firefighting purpose. Okay. 5. A water meter is a device used to measure the quantity of water used by consumer. Water meter are usually installed outside the house and record a reading of the water flowing through it. The user will pay for water depending on the amount recorded by the water meter. 6. With imported equipment in the water supply system, with are used to control the rate of water flow, stop the flow of water, block the direction of water flow, release from inside the pipe and allow air to enter the pipe when the pipe is empty, relieve pressure from inside the pipe, reduce water pressure, remove the dirt from inside the water pipe, and provide a connection to the water supply for the fire department. Storage tank and pond are used to treat water supply before it is distribution to user. Tank and necessary to ensure continuity of water supply during period of water supply interruption. However, the survival of water during a supply cut depends on the capacity of the storage tank. Tanks are also used to stabilize the supply of fluctuating water demand. Okay. This is the sketching of distribution system and selection of justification. Okay. Now, we use pumping system. Okay, first, constant pressure can be maintained by direct pumping into the main. Okay, second, rate of flow cannot be varied easily according to demand unless number of pumping operate to backup. Okay, so third, power failure and breakdown of pump affects supply of water. Fourth, suitable if the sources is lower than user or consumer.
Hi, Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Edina Mete Ahmad. My registration number is 13DKA21F1085. Distribution method at Kampung Mutiara Parit Buntar. If the sources is located at a lower elevation than the target community, this approach is appropriate. Additionally, it has no issue with pressure or keeping the heat on the faucet for the customer. The advantage of pumping system is 1. Water can be pumped only when required. 2. Low water loss due to leakage. And then this one is sketch distribution network. Suitable design sewerage system at Kampung Mutiara Parit Buntar. Sewerage system component drains, underground passageway that transport water to sewage system. Connection, a group of components installed outside of building that link the sewage system to the main drainage network. Stormwater detention pump. Lines that store water from collector to prevent flooding during period of heavy rains. Collectors. They are responsible for gathering and moving water from the drains to the primary collectors. Interceptor outfall. This outfall transport water from the primary collectors to the treatment facilities or other location where it is to be done.
Assalamualaikum. My name is Siti Nur Shahinda binti Ahmad Daud. My registration number is 13TK21F1035. To know our server line meter, we use Manning formula. First and foremost, we need the data to calculate it. So, the data is the number of residents and occupations. As we already collect the data is left on the right. And we assume the flow of the server is full. Then we need to find the population of the Taman Mutiara first. We multiply the residents and occupation. The answer we got is 9,000 people. Since the answer is below 10,000, so our flow rate factor is 6. After that, we find the total flow rate Q. The formula is the multiply of the flow rate, total population, and water requirements per capita. And the answer we got is 171.88 multiply 10 negative powers of 3. Next step, we use Manning's formula to find the diameter. The formula is V equal to 1 divided N, which is roughness coefficient, multiplying the M, which is D per 4, the power of 2/3, and the root of the value I. Since this formula has the unknown diameter, we need to find the diameter. So the answer of diameter is 0.336 meters. That's the diameter of our estimate server. The process of sewerage treatment implemented at Taman Mutiara Parit Punta. In summary, the process involves three treatments. Firstly, the sewerage treatment that is implemented is a primary treatment. This stage is removing the large solids and grit from the surface by screening and sedimentation. The partially treated surface then flow to the next stage. Secondly, the flow will be at secondary treatment. This stage is removing organic matter and nutrients from the surface by biological process. This stage produces the clarified effluents that will flow to the next stage, which is tertiary treatment. The tertiary treatment removes any remaining pollutants from the effluents by chemical, biological, or physical methods. Then, the treated effluents resulting from this stage will be discharged or reused depending on the quality standard of Malaysia. To conclude this case study, my group and I found that water distribution is the process of delivering water from the source to the end user, either as raw water or treated water. It involves various components such as pipes, pumps, channels, dams, reservoirs, and the treatment plants. Water distribution system is essential for ensuring adequate and safe water for all purposes such as agricultural, industrial, environmental uses, environmental, and domestic uses. The water distribution system also requires carefully planning and managing as it involves balancing the supply and demand of water as well as protecting the water quality and quantity in Malaysia. We recommend the parties involved such as in the water and water companies in every state to improve the operation and maintenance of the water distribution system to reduce water losses, leaks, bursts, and contamination. They have to adopt best practice and standards for water distribution system design, construction, inspection, and repair. Other than that, the party involved also can enhance the monitoring and control of water distribution system using smart technologies such as sensors, meters, SCADA, GIS, and data analytics. After that, the government can promote the efficient use of water and reduce the non-revenue water and RW in the water distribution system. For example, implement water demand management measures such as tariff reforms, metering, leakage detection and repair, pressure management, and public awareness campaigns. Then, diversify the sources of rainwater and increase the storage capacity of the water distribution system. Lastly, we need to strengthen the coordination and cooperation among various stakeholders involved in the water distribution system. Establish clear roles and responsibilities Establish clear roles and responsibilities, legal and regulatory frameworks, institutional arrangements, and financial mechanisms for water distribution system management. For example, enhance the participations and consultation of stakeholders such as federal and state governments, water operators, regulators, and consumers.